A particle of mass m is suspended from a ceiling through a string of length L. The particle moves in the horizontal circle of radius r. Find the speed of the particle and the tension in the string. Such system is called a conical pendulum. See, we have already studied about the conical pendulum, and
Yes.
here the question is related to that particular topic. Let's see. This is the ceiling, and I'm going to use a conical pendulum here. Let's say this is the conical pendulum, and it is rotating in a circle. It is suspended from the ceiling, but rotational circle is in the horizontal direction. Let's see, this is the perpendicular from the ceiling to the horizontal circle. This is the horizontal circle, and angle is given side. Length is L, capital L, and the radius of this is R. Theta is not given, just I'm taking it theta. It is not given because we have to use the theta here in our
Good morning,
derivation.
sir.
Good morning. Tarun bete, is there any special? Tarun,
Yes, sir.
what? Kya bete? Tell me what is special?
Yes, sir.
What is special? Tarun, can you tell me what is special? Anything special is there? Between the class, you are just. तरुण, मैं आपको क्लास से बाहर कर रहा हूं. Let's see this question. Here just we have to make the balances, means mark the forces acting on this. Here the first force, that is gravitational force acting on it, and centrifugal force away from the center, and a tension along the thread. These three forces are acting on this object in this situation. Downward force is mg, and here it is mv square upon r, and here it is tension. Since this angle is theta, so we can write here it is also theta. Now resolve the components, because two forces mv square upon r and mg both are along the axes, so there is no need to break the component of these two forces. Just we have to break the component of tension. Okay, see, component of tension along this is t sine theta, and here it is t cos theta. Now, since it is a balanced situation, so just we have to formulate the equation and see what are the equations. T means force in right direction is equal to the force in left direction, because net force acting on the pendulum is 0. Sine theta, T sine theta is equal to mv square upon r, and T cos theta is equal to mg. Any doubt? Any doubt related to this? Good.
No, sir.
Now divide the first equation by second. You will get tan theta is equal to mv square upon r upon mz. So we can write like this. Mm will cancel out. It will be v square upon rg. This is tan theta. Okay. Now what we have to find? We have to find the speed of the particle. See, here we can write v square is equal to rg tan theta. But here theta is not known. So we must have to substitute theta. See, how can we calculate theta? This is r, this is L. L is the hypotenuse and r is the perpendicular for theta. So first of all, we must have to find this length, that is base for this triangle, for this angle. L square minus r square is this side. And if we want to write tan theta, then we have to write perpendicular upon base. Perpendicular is r and base is root under L square minus r square. Okay, so just we have to substitute rg, and tan is again r, means r square, and divided by under root L square minus r square. This is v square. Now making the root, you can find v. Means this is the first part of the question we have solved. Now find the tensor. How can we find the tensor? See, what we have to do, just we have to, there are two ways, just make the square and add them. मैं आपको एकदम जो normal method है उससे थोड़ा सा हट के बताने का प्रयास कर रहा हूं. When a function is in sine, terms of sine, and another is in terms of cos, then just make the square. Make the square of first. We will get t square sine square theta and is equal to m square v to the power 4 upon r square. I have made the square on both the sides. T square again for the second, t square cos square theta is equal to m square z square. Now remove this, add these two, you will get t square sine square theta plus cos square theta, and on this side you will get m square v square upon r square plus m square z square. Okay, this becomes 1, so we can write t square is equal to
v की power 4 है sir.
v की power 4. Yes, v की power 4. Okay, now we can take the common here. M square can be taken as common. V to the power 4, v to the power 4 divided by r square plus z square. Okay, then you can find m square, and see, if we want to put the value of v square here, then it will be square of this, means r to the power 4 z to the r to the power 4 z square. See the things clearly, upon L square minus r square, and one r is already here, that is r square plus z square. It appears little bit complex, but it is not complex. Just you have to be cool and do the calculation. Now it is m square, r will cancel out, here 2 remain here. This can be written as g square, can also be taken as common, and now it is r square upon under root L square minus r square plus 1. This is the e square.
रूट ले आएगा सर वापस।
हाँ हाँ, L square minus R square. Good. And plus 1. This is the value of t square, and you can find easily by making the root on both the sides. Okay, is it clear? Is the question clear? Just copy it, Vijay. I'm just giving you 10 seconds again. We're just moving to the next question. See, this is also the same similar question. You can try it. बेटे आप ट्राई करोगे वही आपका है, मैं बार बार यही कह रहा हूं, मुझे तो बताना है आपको, लेकिन मेरे बताने से आपको जो उतना फायदा नहीं होने वाला है जो कि आपके खुद करने से होगा. जस्ट ट्राई. A simple pendulum is constructed by attaching a bob of mass m to a string of length L fixed at its upper end. Length thread is fixed. The bob oscillates in a vertical circle. It is found that the speed of the bob is v when the string makes an angle theta. It is theta. It is theta. With the vertical. Find the tension in the string at this instant. See, there is a circle, vertical circle. You can imagine the vertical circle. It is the vertical circle. A pendulum is here. It is the lowest position. And when it is, the question is, when it is making an angle theta with the vertical, here, suppose this angle is theta. The velocity of the bob is v. When a string makes an angle theta, speed is v with the vertical. Find the tension in the string at this instant. Okay, it's very easy. You can find it easily. See, how can we solve? First of all, we must have to mark the forces. In this direction, it is tension. And in this direction, it is mg. And in this direction, it is centrifugal force. mv square upon r. I'm just taking r, but L is given. We will substitute L later. Here it is mg. And here it is T. Just try to find the tension. See, how can we solve this question? I'm just drawing the axes along this. Let's say this is the x-axis and this is the y-axis.